Assalamu alaikum and welcome with us again in the DevFest23 talks. I hope you enjoyed the first talk with our ex guest. So I hope you had the most of the information during the first talk. Now with our second talk with Hamza Naciri, who is a software engineer and an SRE at Google, who will talk about why alerting and monitoring are the key. They help us make sure our digital stuff stays strong and reliable. Let's learn together about the best ways to keep an eye on systems and set up alerts when things go wrong. These tips are crucial for keeping our digital world stable. Let's give a warm welcome to Hamza Nasiri and hear what he wants to share. So, welcome Hamza Nasiri, and you take the lead.
Thank you very much, Mr. Man. Thank you for having me here. So I will start by introducing myself. I'm Hamza Naciri, and I am a software engineer in SRE, inside reliability engineer at Google. Well, I joined Google last year, and I am part of the PD Business and Disk SRE team. So today I will be introducing you guys to the alerting and monitoring. So I will start by I will start by like showing you like the importance of like adding alert and monitoring to our systems. So these are like some numbers of how much outages cost like big tech companies, or but not only big techs, big companies are like affected by these outages or like what we call downtime. But there are some big numbers, but also like small startups or like medium companies also like have like carry significant consequences like for these outages. Like for example, it could harm the customer trust and loyalty, but and also like financial. It also acts as a financial threat. So, what is monitoring? So, the monitoring is the process of becoming aware of the state of your system. So, a good monitoring system enables you to see the bigger picture of what is going across your infrastructure, applications, your jobs, etc., and all the time and in real time. So, you want to see the bigger picture of the state of your monitoring system right now, in the past, and in every time. But for example, we want to see like, is my website up and accessible, and was it up and accessible yesterday, and what it is doing all the like it is doing all the work. Is there like any like microservices that are down? Are like the customer are happy? Like, is the latency is like low, or are we like taking so much time to respond to the customers? So these are like some kind of things that you want to monitor to see that, okay, our system in a healthy state, and we are good to go. We are good to go. So before talking about monitoring, I will talk about what are we going to monitor in our system. So we are going to monitor what we call the metrics. So the metrics are raw data that about resource usage, but not only resources usage, but also the behavior of your system. Let's say I'm going to monitor the CPU disk memory usage, how many requests we have per second, how much requests how much time the request takes, like from the client back to the client again, like going to the server and back to the client again, and how much time do we take like to process these requests in our like different services, or if we have like if we have like one service or like multiple services, like which service is taking most time like responding to the user. So the metrics serves as a tool for understanding the present state of our system, for our entire system, and we can use these metrics individually uh, to establish an alerts rules. So we can like use, for example, like the request latency. So if we have like if request latency like uh, passes the threshold of, for example, like 2 seconds, we can say, okay, we will send an alert to the engineer and team saying, okay, our system is not in a good state, so you might want like to troubleshoot or debug something in there. And We could also like group like a bunch of metrics and use them like in a nice and visualize them in a nice dashboard to see like to correlate with them. So it say, okay, the request latency is very high, but at the same time we are getting like a lot of requests. So our system cannot serve all of these requests. So the solution here might be like to vertically scale our system. So why do we need monitoring? But here there are like a lot of benefits or of like adding monitoring to your system. I'm just showing here like the top three things. So the first one is the early problem detection, decision making, and making automations. So by early problem detection, I'm talking about like the availability of the system and the performance. So of course we want our system to be available most of the time. Well, we cannot say that I can make my system available 100% of the time, but I want to make it available most of the time, because like downtime often results in the direct financial losses, because it could also like make us lose customer. And with performance we can talk about a lot of things like performance means a lot of things, and one of them like the most obvious thing is like the time a request like is taken to go into the server and back to the client again. So detecting these kind of anomalies like for availability and performance through the monitoring it is a crucial thing. And we can like like detecting these problems like before they reach the client, because let's say okay, the latency is very high, but like if the latency is very high like for a longer time, it might lead to our system to be unavailable. So if we detect this kind of errors early in time, we can just like prevent like our system to go down entirely. Decision making, we can use this kind of metrics to understand what is the baseline of our system and how our system behaves in its normal stage. And this will allow us like to detect if our system if we are having an anomaly of our system, and if we are having if we are having like a problem in our system. And once again thing about decision once again important thing is like utilizing these data like or these metrics to construct our service level agreement. By service level agreement, I mean like the contract or the promise that you promise your user. Let's say that you are having like for example like you are like a startup and you have like a storage system, and you promise your client that like your system will be available like 99.99% of the time. But we will not you also like promise them that we will not ever lose your data. So you cannot like just say this kind of thing just out of nowhere, but you have to back it with data. And to back it with data, you need to monitor your system and to make sure that you are not like losing any customer data, and that you are available like at the time that you promised your users. And by prediction, we mean like because once we have our metrics, we know like this is okay. This is like the baseline of our system, and this is how much we can. This is how much we can serve. So let's say like we are having like some kind of social event, and we are like predicting that we will have like double like the customer numbers will be double. So we will definitely need like to add more capacity, maybe add more hardware, more RAM, more CPU, or maybe just scale our microservices, adding more replicas for our microservices. But yeah, so this kind of metrics will help us like to predict like the usage or the capacity, or to plan our capacity like for future like events, or like growing our business or our system. And last thing is building automation. So this is the most important part, because we don't want humans to be looking at dashboard like all day long. Because okay, we have our engineers and we want them to do like more work than just like going through the graphs and saying, okay, this is going wrong, this is good, this is wrong. But so we want like to automate everything. So we have our we have like our metrics, and we can like just say, okay, we know that our like system, like our servers can handle, for example, like a thousand requests per second, and we know that like more than that can break our system. So we can just like build an automation that rate limits the rate that like has some admission control or rate limiting once like we go past this threshold. So for example, like in this picture, let's say that the user can only send 2 messages per second, because like if we do more than that, we will be just breaking our system. So building automation is like is the most important part, like about monitoring and alerting. So I'll be explaining the monitoring system architecture, and yeah, so a monitoring system architecture can be built upon 3 things. First thing is data collection, then we have the data aggregation and storage, and finally we have the presentation. So by data collection, we mean like it is obvious. So we have a lot of data sources. We have the logs. We have device statistics, like let's say the hardware, CPU usage, memory usage, and the things that related to hardware. And we also have system measurements. We can say that like or I mean like here I mean here like the application measurement. And we want to literally record everything or anything that will help us decide if the system is behaving normally or not. Let's say, for example, like how many request failures do we have, or like how many requests do we have, and we would also like to record like the status of this request. Is it 400, 300, or 500? Operation rate, latency. These are like some example of things data that we can collect. Once we have all this data, we want to aggregate all this data and store it somewhere, because we'll be using it later on for either presentation or setting up alerts. So, there are like a lot of systems used to like data aggregating these kind of metrics and storing them. Like the most famous one is Prometheus. It's an open source software used uh, for for metrics and like storing them. And it also have like this kind of like visualization tool, but like it's not like the most important thing about Prometheus. So yeah, let's say that we have like our our metrics stored, and we want to evaluate we want to evaluate these metrics, and either we want to just store them or like build them into alerts, and we will just like do something with these metrics once we have them stored. And the last thing is presentation. So we want to have some kind of dashboards to visualize the real time state of the system. And this presentation is powerful because we want to visualize the state of the system once something has broke. So we know that the system is in a bad state, and this kind of visualization can help us correlate like the problem, correlate the problem, the different metrics, and figure out like the problem right away. The second thing is, once we have identified and fixed the problem, we can use the same metric again, because like it is the real time state of the system. So we can use it again to verify if our the fix that we have rolled out is working properly, and we should immediately see the fix shown in these kind of graphs or dashboards. Well, I didn't prepare any demo or anything, but I have this like an old project that I've worked on, and I have integrated I integrated Prometheus and Grafana in it to export metrics. So this is like how it looks like in Prometheus UI. So for example, here we have like the HTTP server requests count per second count, and if you see in the like the properties of this metric, we have the outcome. So the first one says client error, and the count is 5. So I had like 5. I had like I don't remember like the time window for this one, but I had 5 client error HTTP requests, and I also had like some success requests. So the second thing I did is I built this thing. So the same metric, I built it up in Grafana, which allows you. So Grafana is like it's also an open source software that allows you to visualize this kind of these metrics in a nice dashboards and graphs. So it's the same metric again, but it is like it is visualized in a nice way. And we also have like some built-in things that comes with with Prometheus, which is like this, we have, for example, here we have the system CPU usage as well. And the last thing here is set up some. It is also part of Prometheus, so it's kind of a plugin that you can plug in into your Prometheus software, and it allows you to set up some alerts. For example, here I had some alert that will send a notification for me in email saying that some instance is down. So we'll be talking about this alert in the next slide again. So alerting. So alerting is the capability of monitoring the system. So we have we are monitoring the system, but once we detect something is wrong with the system, we want to notify the engineer about it. So it's not like just something is bad, but all meaningful events we want to notify engineers about it, because we set up alerts because so that the engineers are aware about everything that happens in the system. So we have 3 levels of urgency. I can say like we have only 2, but like let's just say we have three levels of urgency. So the first low level one is record. So once we have this is like some anomalies that does not impact the surface functionality, but there are like some minor things that we want to troubleshoot, but we want to troubleshoot on debug, but not they are not like some urgent thing. If we will leave them there, they will not like impact the system in any way. So there are like some things that we want to improve, but like it's not very important. So we can just like record this kind of thing as a record, and we can just come back to them later once we have like time to do these things. And the second thing is notification. So the kind of thing that I was showing here, this is like a great example of notification. So something is wrong with my system. So an instance of my job is down, but this is not affecting the system. So this is not like something that I want to fix immediately, because I still have a lot of instances up and running, and they can serve clients. So this is something bad, and I want to investigate why my instance is down, because this shouldn't happen normally, but this is not something urgent that I need to address immediately. So I have to do it, but it can just wait. So this is what we mean by notification. It does not require immediate attention, but it is something that needs to be addressed. And the last thing is pages. So pages is some kind of alarms that notifies you, and like it can wake you up like in the middle of the night because something is wrong and needs an immediate attention. And this kind of things are we call it high severity, because like most of the time it is enforced by internal SLA. And I explained earlier that SLA are things that we promised our clients. So we promised our clients, for example, that the system will be available all the time, but let's say that in a region, our website is down, so no one can access it in this region. So we need an immediate response in there to see why this is happening, and we need also uh, to uh, to make our jobs like or our website up and running in this region. So this is like the three level of alerts. Let's say that notification can be sent as an SMS, email, or anything like as a or anything. A record, like you can just like store them in your own database and you can just come back to them later. And for pages, there are like a lot of software used for this kind of thing. And the most famous one I think is PagerDuty. So it's just like you can set up on your phone and it will just like set up an alarm once something is wrong with your system. So we have set up alerts, we have monitoring, we have alerting, and okay, we got alerted, we detected the issue, we fixed this. Are we done? No, not yet. So we have fixed the issue. Okay, that's good. But identifying and resolving the issue is not the initial measure. It is also crucial to prevent these kind of things to happen again. Because okay, we just like did a quick fix because the system was down, but we need to do something to prevent these kind of things to prevent this kind of thing from happening again in the future. So postmortem are kind of actions that we need to take to reflect on what has happened and what can be done to prevent the reoccurrences of these kind of things. So I will not go. I think I'm out of time, so I will not be going through the postmortems, like or like the definition of postmortems, but like I will just explain just two, which I think like the most important thing about postmortems, and they are like the root cause analysis. So the postmortems will include the root cause analysis. So once we have fixed everything, and once we have detected the issue, we have a fix. It might not be like a long-term fix, but something that has fixed the issue and the system is running again. So we will do a root cause analysis. So what was wrong and why this is happening. And once we have these root cause analysis, it will allows us to improve our system, not only at this moment, but we will be able to apply a long-term fix if we have not yet done this thing, and we will also learn from our mistakes and not apply it again in our future, let's say, services or applications. And I think that concludes my presentation about alerting and monitoring. I know I didn't have any kind of demos, anything, so it might have been boring, but it's just like a quick introduction to systems alerting and monitoring. So if you have any questions, please feel free to ask. Oh, I see that there are like some questions that, well, I didn't see them because I was presenting, and well, Nopal say that earlier on questions, your title is very interesting. You do software engineering and SRE at the same time. Yes, actually. So well, my job title says software engineer inside reliability engineering. So my job not only includes site reliability engineering, which is like making sure that our product is reliable, but also building automations and building tools to help with doing that. So it is software engineering, but we are not like building the product itself, but building on top of the product to make it more reliable. I hope that answers your question. So if yes, can you give me your perspective on whether software engineering is included in SRE or DevOps practice, or is it the other way around? Well, I would say that SRE is very different from, well, I would say like it's very different from DevOps because we are not like doing DevOps like in well in my job I'm not doing like DevOps, but as I said earlier, we are like building automations and building on top of the product, not only automation, but on top of the product. So we have like two separate teams. We have the dev team, the SRE team. Once with dev team has like, okay, we have a new feature. We have a new feature. We want to deploy it in prod. And we as SRE, we say, no, it's not ready yet. We need to add like some touch on top of it to make it like more reliable because we know production environment more than devs do. So let's say that the new feature that you have added will like eat a lot of CPU. So we cannot like just like deploy this kind of thing. So we need to build on top of it or optimize it or do something like that to make it like more reliable and to make it ready for production. This is only part of the job, and the other part is building automation to making triaging or like fixing the issue happens automatically. Because like we don't, as I said earlier, we don't want humans to be fixing the issues manually again and again. We want to build automation to do this instead of us. I hope that answers your question. Well, there are like some kind of things that you want to to monitor and log. Like for example, let's say I'm building a service that like let's say that I'm building like a basic website. So the first thing that comes in my mind is like I want to. So the first thing is they're like what we call like the black box monitoring and this kind of thing that like that you can monitor outside of the system. So without going inside of your application, you can just monitor this kind of thing. So let's say that CPU usage, memory usage. Let's say how many requests your applications like is coming to your applications. So this kind of thing we want to monitor them because this will not only give us like the state of the application, but also how is the hardware is like maintaining your application. So let's say like that you are like serving a lot of your requests. This is not like a problem with the logic of your application, but let's say that the hardware is not like it cannot like handle all of these requests. So you might want like to add more replicas and more hardware, or like add more CPU or something like that. And there's also like the what we call like the opposite of the black box monitoring, which is like some kind of things that is related to the logic of your application. So let's say in the logic of your application you have implemented some kind of rate limiting, and you want also to say to monitor this rate limiting things, how much you are rate limiting your clients. Because like from the point of view of your clients, of the clients, they will say, okay, we have sent the request, but it's taking too much time. But from your point of view, we say, okay, I have received the request. Okay, that's fine. But then this client has a lot of requests, so I'm rate limiting them. So it makes sense that they are like suffering from a high latency. So nothing is wrong. So nothing is wrong like with the system at the moment. It's just like the normal behavior. Yeah, about Prometheus, I think you mentioned that. Can you elaborate the difference between Prometheus and the Grafana AI? So the difference is pretty simple. Prometheus is the system used to collect metrics. So it collects your metrics that you send from your application or from your system and store it. So it acts like as a storage system. And the Grafana is pulls pulls this data from Prometheus and shows it in a nice and and visualize it in a nice way. So you could like just say Prometheus is the back end and Grafana is the front end of this like monitoring system. But I think that Prometheus also have this visualization thing, but people prefer Grafana because like it looks nicer. And also you can plug in Grafana with many other monitoring system, not only Prometheus. I'm just saying this because Grafana is not only for Prometheus. You can also plug in a lot of monitoring system with it.
So thank you all for joining us, and thank you, Monsieur Hamza Naciri, for this outstanding talk. And that's it. So we've learned a lot about the importance of alerting and monitoring from Hamza Naciri, but tomorrow there are more to explore in the DevFest23 talks. Hosted by GDG Algiers, of course, we invite you to join us again for another exciting day of learning and inspiration. And Assalamu alaikum, and see you tomorrow at DevFest23 talks. Thank you so much.
Thank you very much.
Thank you.